Hi there. Hope you have a fantastic day today. This lesson I will teach you limiting sum. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. So we need to find the sum of this series. So the first term, A, is 18. So let me just write this down. So A is the first term, that is 18, and we need to find the common ratio. So the common ratio for this is R is equal to term 2 over term 1, or can be term 3 over term 2 or term 4 over term 3, so on. Okay, so in this case I just use term 2, that is 12, divided by term 1, that is 8, so it's 18. So that will give me, so if I just quickly simplify this, or of course you can just put that on a calculator, both divided by 6, so that give me 2 divided by 6, give me 3. So the common ratio is 2 over 3. And since the common ratio is between -1 and 1, the formula to use for finding the sum of this series is S of n is equal to A 1 minus R power of n over 1 minus R. Now n is approach to infinity. So therefore, sum of infinity is equal to A. A is 18, 1 minus the common ratio, that is 2/3. So 2/3 bracket 2 over 3 and power of infinity. So that brackets over, let me change this a bit. So over 1 minus 2/3. Now, if you think about it, let's just use calculator to work it out. So let me just work out the 2/3 power of a number first. So let me bracket 2 over 3 and power, let's say power of 2. So that gives me 0.44. Let's change 2 to, let's say, 10. So 0.017 and so on. It's getting smaller. So if I try 20, so it get even smaller. So if I try, let's try 40. So you can see 2 over 3 power of a large number is approach to 0. So this means that this becomes 0. So therefore, the answer is equal to 18 we times by 1, because inside here it becomes 1. So 18 times 1 is 18 over, now 1 minus 2/3 will give me 1/3. So 1/3. So that is equal to 18 times 3. And we know that 20 times 3 is 60, and we less 6, so 54. Otherwise, you can just put on a calculator, you should get 54. Or you can just simply put in a calculator 18 divided by 1/3. You should get 54. So to find the limiting sum, so we need to know that the series here must be approaching to 0. In another word, so R must be between -1 and 1. So in order limiting sum to exist, R must be between -1 and 1. Keep that in mind for me. So we need to use this formula, of course. S of n is A 1 minus R power of n over 1 minus R. So in fact, so if we want to find the limit of R power of n when n approach to a really large number, that is infinity, so therefore the answer for this is 0, because a number between -1 to 1 power of a large number, it becomes 0. So keep that in mind. So this means that this becomes 0 when n become a really large number. Keep that in mind. So therefore, sum of infinity will give me, because it's 1 times A is A, and then over 1 minus R. So please keep that in mind. Okay, sum of infinity will give me A over 1 minus R. And the condition is R must be between -1 and 1. Okay, please keep that in mind for me. Second one. So we need to find the limiting sum for this. We know that the series is approaching to 0, if you like, because R must be between -1 and 1. So let's just work it out. So we know that A is 36. And to find the common ratio, R is equal to -18 over 36. I just use term 2 over term 1. And we know that 18 over 36 is 1 over 2. So that means equal -1/2. Of course, you can just put on your calculator and you should get -1/2 or 0.5 negative if you like. So we know the rule. The rule for limiting sum, S of infinity is equal to A 1 minus R. Just remember that for me, okay? So therefore, that will give me S of infinity is equal to A. A is 36 over 1 minus the common ratio. And in this case, the common ratio is -1/2. So -1/2 if you like. So now what I do, I can just put on a calculator or I can just simplify this first. So 1 minus -1/2 becomes 1 plus 1/2, which is 1 plus 0.5 if you like. So 1.5. So the answer is 36 divided by 1.5. And I just put on a calculator. So I just go 36 divided by 1.5. So there you go, 24. So sum of infinity is equal to 24. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, we know that A is equal to 2. And the common ratio for this R is 1.5, easier, okay? Term 2 over term 1. So therefore, R is equal to, so just go 1.5 and I divide by 2. So 0.75 or 3/4 if you like. So I just quickly write down 0.75. And we know that this limiting sum or sum of infinity is equal to first term, that is A, over 1 minus R. So 1 minus R. So therefore A is 2. So which is 2 over 1 minus 3/4 or 0.75 if you like. So I just put 0.75. So that will give me, so I just go 2 over 1 minus 0.75. So there you go. The answer is 8. Second one. So we know that A is -9. And the common ratio, R, will give me 6 over -9. Of course, I can simplify this by simply divide both by 3. That give me 2, that give me 3. So -2/3. And we know that the sum of the infinity or limiting sum, if you like, is the first term over 1 minus the common ratio. So A is -9 and the common ratio is -2/3. So 1 minus -2/3. Of course, 1 minus 2/3 is exactly the same as 1 plus 2/3. So give me 1 and 2/3. So that will give me, -9 over 1 and 2/3. So that will give me, so let me just put down a calculator, -9 over shift fractions 1 and 2/3. So there you go. So shift SD, so -5 and 2/3. So -5 and 2/3. third. So there you go. And I hope you got all of them correct. And thank you so much for watching. Bye.